Hello everyone, in this video we shall solve a simple yet an interesting problem in electrostatics that illustrates Coulomb's law. The beauty of this problem is that it takes few steps to solve, yet you need to think deeply in order to understand it fully. So, as in case of any problem in physics, pay more attention to understanding the event step by step and not blindly apply formula to get solution. So, let us begin the problem. So, here is the problem statement I will read out. Consider the case of moon moving around earth. Now, assume a hypothetical scenario in which both earth as well as moon get a charge of q coulombs distributed throughout their body. Due to this sudden change, the orbit of moon around the earth gets disturbed, resulting in a new orbit. So, what should be the value of the charge q in order for the moon's orbit around earth to become 4 times its initial value? So, I will read out the problem again. Consider the case of moon moving around earth. Now, assume a hypothetical scenario in which both earth and moon get a charge each of q coulombs uniformly distributed throughout their body. Due to this sudden change, the orbit of moon around earth gets disturbed, resulting in a new orbit. So, what should be the value of charge q in order for the moon's orbit around earth to become 4 times its initial value? So, some important data has been given. Mass of the moon given by small m is 7.347 into 10 power 22 kg. Mass of earth capital M 5.972 into 10 power 24 kg. Radius of moon's orbit 3.48 into 10 power 8 meter. So, the problem is simple. We have moon orbiting earth in a circular orbit. This is the initial scenario. Now, both earth as well as moon suddenly acquire a charge due to some mysterious conditions, the charge being equal in both cases. So, what happens? Well, an electrostatic repulsion between earth and moon develops, which pushes them far away from each other. So, according to the problem, the requirement is what should be the value of the charge q such that this repulsive force does not cause the moon to totally escape earth's gravity, but indeed shift to a higher orbit. So, what should be the magnitude of charge q to get the desired radius? So, as shown in the figure, we have the circular orbit of moon around earth. The moon is having speed v, orbital speed v, and orbital radius r as shown in the figure. So, obviously, in this case, the gravitational force of earth on moon provides it the necessary centripetal force to maintain the circular orbit. So, we know that centripetal force is given by the formula mv square by r, and the gravitational force according to Newton's law of gravity is g m1 m2 by r square. Here m is the mass of earth and small m is the mass of moon. So, the gravitational force acting on moon according to Newton's law of gravity is g capital M small m by r square. So, in this case, the gravitational force and the centripetal force are one and the same. So, g m by r square is equal to small m into v square by r, because centripetal force on an object moving in a circular path is mv square by r. So, both are equal. From this we get the orbital speed of moon v is equal to square root of gm by r, where g is the universal gravitational constant, m is the mass of the earth, and r is the radius of the earth moon orbit. So, we have got the orbital speed of moon from this equation. By substituting the values, that is g 6.67 into 10 power minus 11 and mass of the earth is 5.97 into 10 to the power 24 kg and the radius of the earth moon orbit is 3.48 into 10 to the power of 8 meters. So, substituting in the equation, we get the velocity orbital speed of the moon as approximately 1069.69 meter per second. Now, let us keep this orbital speed aside. So, according to the problem, both earth and moon are given a charge q, that is the second case, whose value we need to find out. So, what happens when both earth and moon acquire this charge? Well, as we know that two positive charges repel each other, so earth and moon will repel each other, and obviously they move far away from each other, because you see the repulsion force caused by the electrostatic force is in a direction opposite to the gravitational force. So, an additional force Fe acts on the moon, causing the moon to move away from earth into a higher orbit, because this is the condition required. The moon does not completely escape the earth's gravity. Say the moon now moves into a new radius r dash. So, in this r dash, the moon settles into orbit around earth. So, the new centripetal force acting on moon Fc is equal to Fg minus Fe. In the previous case, Fc was equal to Fg, but here the new centripetal force is Fg minus Fe. But although the orbit of moon changed due to the additional force, the orbital speed remains constant as before. Why? Because the change in centripetal force is still perpendicular to the velocity. So, the orbital speed has not changed, but the orbital radius increased. So, Fg minus Fe is equal to mv square by r dash. R dash is the new orbital radius of moon around earth. So, it is a simple straightforward solution. Fg is nothing but gmm by r dash square, because the new radius is r dash, minus, now comes the new term, the electrostatic force. Here earth and moon can be considered as the point charges, because they are very far from each other. So, the force between them is governed by Coulomb's law, which is k q1 q2 by r dash square is equal to mv square by r dash. So, solving the equation for q, here q1 and q2 are equal, because both are given equal amount of charge. So, it becomes q square. So, gmm by r dash square minus kq square by r dash square is equal to mv square by r dash. So, you can eliminate r dash, one r dash on both sides, you get gmm by r dash minus kq square by r dash is equal to mv square. So, solve this equation for q. A step ahead, bringing all the terms except q onto the other side, because all these values are known. R dash, the new radius, which is 4 times the initial radius, we know the value of g, mass of earth, mass of moon, and the orbital speed. From this we can get the required charge, so that the new orbit will be 4 times the initial orbit. Thank you.